This is the second one I've done on the Singapore Mathematics Olympiad 2011 Junior problem number 12. And I just did the first part of this as a separate video because I thought it was pretty difficult to actually figure out what to do in terms of the algebraic simplifications. But you'll notice here we're given an initial condition, and we're supposed to evaluate this entire expression. So this is a quartic equation divided by a second degree equation. And so, of course, one brute force way of doing it would be to sub x everywhere you see an x. And of course, just this very first part, raising this to the fourth power by hand would be a burdensome, thankless task, error prone and all that. And so we're looking for another approach here. And it turns out that we can actually evaluate the denominator fairly easily and then use long division down here to evaluate the entire expression. Now, something that's very, very handy here, and the problem's kind of designed to work, is if you'll take a look right here, you'll notice that, and I didn't notice this at first, I just not that alert, but you'll know that it's not hard to note that 19 plus 8 root 3 is just equal to 4 plus root 3 quantity squared. Okay. Now again, that's not too hard to see because 4 squared is 16. Then you have 2ab, that's 2 times 4 times 3 is the 8 root 3. And then you have root 3 squared, which is 3. So 16 plus 3 is the 19 that you see right there. And so this works out very nicely going from here to here. We replace this with what it's equal to, but then the square root of something squared is just a something. Okay, that's nice. It's just a square root function, and the squaring functions are inverse functions. And so we do the standard trick. We multiply through by the conjugate surd. So in other words, right here, if we multiply this guy right here if we multiply 4 plus root 3, let me just write it off to the side here. 4 minus root 3. If we multiply this guy by 4 plus root 3 times 4 minus root 3 is going to give you 13 right here. Now notice we just did it. We just multiplied at top 4 minus root 3 also. In other words, we're multiplying through by 1 in kind of a clever way. But again, the difference of two squares, 4 plus root 3 times 4 minus root 3 gives you 16 minus 3, which is equal to 13. All right, and then the 13s cancel right here. And so we actually get that x is equal to this circle expression right over here. All right, but that means if we subtract 4 from both sides, right down here, we get x minus 4 is equal to minus root 3, and x minus 4 quantity squared is equal to 3. Okay, so that's kind of the big discovery from the initial condition. Now, notice, though, that connects right back to this denominator here. X, I'll just write it right here, x minus 4 quantity squared. X minus 4 quantity squared minus 1 is actually equal to this denominator. Isn't that cool? It's equal to that denominator. So it's x squared minus 8x. All right. Plus 15. Okay, but we know that x minus 4 quantity squared is equal to 3. So if you subtract 1 from 3, you get 2. So we get that 2 equals x squared minus 8x plus 15. Okay, now that's super handy right down here. In fact, we're practically done with the problem. Now I left out the steps, the the long division that was required to do this. I didn't want to clutter up the screen and make mistakes in front of you guys. So, but when you do the long division, this is what you get. You get x squared plus 2x minus 1 as the quotient. You get 38 minus 20x as the remainder. And of course, the remainder goes over the divisor, which is yours truly. All right. Now, so the rest of it's fairly straightforward here. We put the 2 right here. Remember, x squared minus 8x plus 15 is equal to 2, right? Okay. X squared minus 8x plus 15 is equal to 2. So that's where this 2 comes from right here. Okay, now I did a little bit here. 38 divided by 2 is 19. 19 minus 1 is the 18 that you see right here. Minus 20x over 2 is minus 10x. Combined with 2x gives you minus 8x, right? And so right here, folks, this you could think this is just being written as x squared minus 8x plus 15, right? Plus 3. Now, you probably didn't need to see that step, but just in case, plus 3, right? Last time I checked, 15 plus 3 was equal to 18, right? Now, we've already, all of this work up here led to this important truth that x squared minus 8x plus 15 is equal to 2. So that's where the 2 plus the 3 comes from, right? There's the 3, and x squared minus 8x plus 15 is 2. I thought it was pretty neat. So this is the final answer. And again, this is just a junior problem. And I had to look at the solution. I kind of got started on it, but I didn't know what to do. I really couldn't even get to this point in the problem. I didn't see how important that was. You know, I didn't even notice this part right here. I was trying to subtract 4 and do it the hard way. So in any event, I guess you'd call this denesting the radical. At this stage right here, we denested this radical and got a perfect square. Okay, and then we just took advantage of the relationship between the square root function and the squaring function. All right, let me know what you think.